again, and I had to do a retake because apparently the sound in the previous video was not working. So I'm here to talk to you again about log rules. There are three major rules that I want you to learn about in this video, and that is product rule, quotient rule, and power rule. And all of these rules are dealing with logarithmic. So this is the product rule with logarithmic, quotient rule with logs, and power rule with logs. And so we'll end the video by also talking about the transition from logarithmic to exponential. I know I talk about this in another video, but I want to talk about it again. And then I'll also talk about common log and natural log. Okay, just real quick, just to tell you about that. But let's start out with some of the basic rules on logs, and we'll start out with power. So the power rule says, and this should not take that long, but let's see how it goes. The power rule says that if you have two logs, right? Let's say we have log base b of a plus log base b of capital B. If we have two logs with the same base and they're added together, what we can do is combine the capital A and the capital B together by multiplying them and put them together in the same log. Okay, I'll put this in parentheses so we know that those are together. Okay, this is called the product rule for logs. I don't need that S on there. Product rules. So this is the product rule for logs, and it just says if you have two logs with the same base, having the same base is very important. If they have the same base, then you can combine them together by multiplying whatever you're taking the log of. So if I threw numbers in there, let's say I have log base 2 of x plus 2, and then I also have log base 2 of, let's just say x. Make this even simpler. Let's just say this is log base 2 of x. And I'm adding these two things together. So because this is an addition with two logs in the same base, what I can do with the x plus 2 and the 2 is I can multiply them together. So if I was to multiply x plus 2 times x, that would basically be, it would be x squared plus 2x. Because it's like I have to distribute, right? If I have x plus 2 times x, then in order to multiply these together, I have to basically distribute that x inside. Okay? So let's look at another one. Let's say if I have log 4 of x plus 3, and then I have log 4 of 3x plus 1. And I want to combine these together as one log. So because they have the same base, I'm going to keep the base the same, right? So this is going to be log base 4. But then I have to multiply x plus 3 times 3x plus 1. Now, if I was to look at this, I need to multiply these together, right? So in order to multiply these together, I'm going to have to do the FOIL method. I'm going to have to distribute, okay? I'm going to have to do x times 3x, x times 1. So 3x squared plus x. Then I have 3 times 3x. That's 9x, and 3 times 1, that's 3. So what I get when I multiply this stuff together, if I combine the like terms in the middle, that's going to give me 10x and then plus 3 at the end. So when I multiply those two binomials together, I get 3x squared plus 10x plus 3. So that's what I get here. 3x squared plus 10x plus 3. So this is my answer right here of how I combine these two logs together. Okay. I'm going to erase this part so I have more room. One more thing I want to point out. This also, you could go backwards with this, right? So what I mean by going backwards is, let's say I have, let's say if I have, because I saw some problems like this. Let's say if I have log base 8 of two things. Let's say x squared and y. Okay. Now, if I am taking the log of two things right here, I have log base 8, x squared, and y. They're multiplied together. Because they're multiplied, if I think about the rule backwards, if you're multiplying, then you can split them up into two different logs by adding them together. So if I did log base 8, I have x squared, and then I put a plus sign, I can do log base 8 of y. So just letting you know you can go backwards. Some of you that are familiar with log rules probably see that, oh, you can also use the power rule, but we don't know about the power rule yet. So we're just going to stop right there. I just want to make sure you understand the product rule. So this is the product rule. If you have two logs, you can bring them together as one. If you have one log, you can separate it into multiple logs by using a plus sign. Okay? So that's rule number one. Let's look at the next one. So the next rule is called the quotient rule. So the quotient rule says, let's say if I have log base b of a minus log base b of capital B. So I'm having to subtract these two logs now. They have the same base, but now you're subtracting them. So in order to bring this together as one log, instead of multiplying like we did with product rule, we're actually going to divide. See? So subtraction corresponds to division. Addition corresponds to multiplication, product, okay? So let's say if I have, I'm pulling some examples from my tablet here. Let's say if I have log 3 of x minus log 3 of x minus 4. And these are two logs, same base, and it's a subtraction sign. So the subtraction sign is saying that if I have log base 3, then in its subtraction, then I would divide these two things. I would do x divided by x minus 4. The first one always goes on the top. The second one goes on the bottom. And then that will be your final answer if they want you to combine it into one log. You would, if you divide, always make sure you can't reduce. So when you divide, make sure to look at your final answer and make sure that you can't reduce it. Like on this one, x over x minus 4, there's nothing to reduce there, right? But let's look at an example where it may reduce, because this is very important that we understand that. Let's say if I have log x squared minus 4 minus log of x squared minus 5x plus 6. And the directions are saying, can you write this as one log, okay? So I know that the subtraction sign means division, right? So I have the log stays the same. This is called a common log. We'll talk about at the end of this video. So I have log of, at the top, I have x squared minus 4. At the bottom, I have x squared minus 5x plus 6. And instead of me walking away and saying, okay, I've divided them, I'm done, you actually want to make sure they don't reduce. And the way that you see if a fraction reduces is you have to factor the top and factor the bottom. If anything looks the same on the top and bottom, you have to cancel it out, basically. So what I want to do is, let's look at this separately. Let's go over here and say, okay, if I have x squared minus 4 at the top, and then x squared minus 5x plus 6 at the bottom, let me factor the top and factor the bottom. And if something cancels out, I reduce it, and then I will have my answer. So at the top, if I was to factor at the top, that's the difference of two squares. So that's going to be x plus 2 and x minus 2, difference of two squares. If you need help with factoring, I have a video on that. And at the bottom, if I was to factor, it will be x minus 3 and x minus 2. Multiply, I get positive 6. If I add those, I get negative 5. So boom, I have it completely factored. Now, if something looks the same on the top and bottom, it has to go away. And if you look at this, x minus 2, they both have x minus 2, they need to go away. So if I was to reduce this, the reduced form would be x plus 2 over x minus 3. That's what I get when I reduce it. So therefore, my final answer here, instead of this part right here being my final answer, I actually need to go one more step. Go one more step here and say, okay, this is going to be log. At the top, we have x plus 2. At the bottom, we have x minus 3. This will be your final answer if they ask you to write it as one log. Okay, and I'm going to erase this because I don't want you to think that this is equal to what I have over here. I'm going to erase this part. So if I want to combine these two logs together and they're subtracted, it's going to be equal to this right here when you reduce it. Okay, and again, if you need to go backwards, let's say you need to go backwards, right? Because we're doing all this. If I give you multiple logs, combine them together as one log. What if I give you I'm always doing this x squared, right? Okay, what if I have this and I ask you to write this as multiple logs? Because you see division, what you would do is you would say, okay, this is the same as saying log 5 x squared and then minus log 5 x minus 5. And again, those people that know power rule are probably looking at this like, oh, you can go one more step. You can go one more step. We just haven't learned that part yet. So be patient. For right now, I just want to make sure you understand the quotient rule. Subtraction means to divide. Divide means subtraction. Okay? Last rule is the power rule, the one that I keep talking about. So the power rule says, and let me pull my examples up. So the power rule says that if you have log base b of a, and let's say a is raised to a power, I'll call that power n. The power rule says if you have an exponent, then you can take that exponent and bring it down right in front of the log, okay? You can take it from the position that it's in up in the exponent position and basically bring it down to ground level. So this would be n log base b of a. All I did was, I'm going to rewrite this because I don't like the way I wrote it. All I did was take the n and put it right in front of the log base b of capital A. So now that n power is not there anymore. Instead of the n being up in the exponent position, I took it to the front. So if you see an example of that, log 5, let's say x squared, like I keep talking about x squared, right? So instead of leaving it as x squared, I can take that power and bring it down to the front. That power of 2 can be placed in the front. So this is the same thing as saying 2 log 5 of x. Okay. And likewise, let's say we have something like this. ln, which is a natural log, I'll talk about that in a minute, ln x plus 3 to the, let's say, to the 4th power. So that 4 can come down to the front in front of your ln, and this would mean the same thing. Okay? If we go back to the previous problems, the ones that I kept talking about, right? Let's go back here. So this problem right here could go one more step, right? I can bring that 2 to the front, and it will be 2 log 5 of x. And then you keep the rest of this the same, right? Let's go back even further. Where was it? Right here. Look at this right here. The power rule says that 2, if I want to expand this further, you take that 2 down in front of the log. Keep everything else the same. Okay? Just wanted to point that out. So that's the power rule. If you have the quotient, the product rule, the quotient rule, and the power rule, then you are good to go with solving a log equation, because that's the main goal. Now, before I wrap up this video, I want to talk about 2 things. And this is just some extra stuff. So another rule that I feel like is helpful, and this is just from looking at my math lab and homework problems and exam problems. If you have a situation like this, and you'll see something like this in your homework probably. So let's say you have log base b of a is equal to log base b of capital B. Same base, same log, okay? Same log, same base, say it again. If they are exactly the same and they're equal to each other, then, I'll make sure it's good. Okay. So if you have the same base and they are equal to each other, I want to make sure my video is going. You can basically ignore these logs and say that A is equal to B. Okay? So let's say we have a problem like this. This is an example that I saw from the homework. Log base 3 of x plus 3, and then log base 3 of 3x plus 1, okay? Let's say if we had this. Now, there's ways that you can solve this by putting all the logs on one side, but if it's the same log, same base on each side, then you can basically cancel out. If something is the same on both sides, you can cancel them out. Okay, those are going to go away. And then this turns into a simple problem, right? X plus 3 and 3x plus 1. Now I can solve for x on this problem, okay? I'm not going to finish this problem, but I'm trusting that you can go through and solve for x. I'm just getting you started with it, okay? You would move the x over, you would move the 1 over, you end up getting the answer. So that is one of those rules, and it kind of corresponds to, in a previous video, we talked about bases being the same. So if I had a to the u power is equal to a to the v power, if the bases are the same, again, you can ignore the base and just say u is equal to v. Now, an example of that is, like, let's say we have 5 to the x plus 3 is equal to 5, 7x minus 1. Let's say we have that. the bases look the same, right? If the bases look the same, ignore the bases and just set the exponents equal to each other. And solve for x. Again, I'm going to trust that you're able to solve for x. If you don't know how to solve for x on this, let me know. But you would move the x over and then move the 1 and solve for x. Okay? Good, good, good. One more thing. This is the last thing I will talk about, and that is log notation, exponential notation. Actually, there's two more things I want to talk about, but let's just go here. So log notation. Let's say we have log notation. Y is equal to log base b of x. This is considered to be a log notation because it actually has a log in it, okay? log. So this is considered to be log notation. There are some problems that are going to ask you to take log notation and change it to exponential notation. Exponential notation, if I want to take this problem that's in log notation and change it to exponential notation, I want you to listen real quick. So I have y is equal to log base b of x. Y is equal to log base b of x. So exponential notation is going to start with the base. The base is b. And you see how b is with x? Those are going to switch now. The x and y are going to switch because logs and exponentials are inverses of each other, and inverses means the x and y switch. So instead of b being with x, b is now going to be with y. So this is the base b raised to the y power is equal to, instead of the y being by itself, it's the x that's going to be by itself now. Now, this is very important to understand how these switch back and forth, because this is going to be how you solve an exponential function. Okay, so we have log notation and we have exponential notation. So how can this be used? So in the next section, when we're talking about solving a log equation, so let's say if we had something like this. And I am definitely just making this up off the top of my head because I don't know. Okay, let's say if you have something like this. So the only way you can solve this problem is if you change it to exponential notation. So right now it's in log, right? Because you see log. If I took this problem and changed it to exponential notation, then I can actually solve it. So what's the base of this problem? The base is going to be 3. Now, the base 3 is with the x plus 4. I want to switch those. I want the 3 to actually be with the 2 now. And then I want the x plus 4 to be on the other side. So this is going to be 3 to the second power is equal to x plus 4. Now this is turned into a problem that I can actually solve. So if I do 3 squared, that's 9. And then I move the 4 over, I get 5. I get x is equal to 5. So that's the benefit of knowing how to do log notation and exponential notation. Like, you really need to know how to do both. Okay, now this will be the last thing I'm talking about. And this is the common log and the natural log. So common log, if you ever see a log that doesn't have a base, and you saw me do that a couple of times in these problems. So like this right here doesn't have a base on it, right? If I see log x, this doesn't have a base on it. If you don't see anything there, then the base is going to be 10, okay? If you don't see anything in the base position, the base is going to be 10. So for these two problems, I could write it like this. Base, log base 10, x plus 3. And then this one could be log base 10 of x. I could write it like that, okay? Common log is the log that's on your calculator. If you look on a graphing calculator, let me see if I can pull mine up. If you look on a graphing calculator right here, across from the 7, I don't know if you can see my cursor on this, but across from the 7, you see log. That log, if you use that in your calculator, it has a base of 10. So if I put log right here, you see how it just shows up log? It doesn't put a base on it. The base is automatically 10. Okay, this is a common log. So another log that is used is called the natural log. Now, natural log looks like this: ln x. ln x minus 7. Okay, ln, you saw me use that earlier in the video. So ln, if you see ln, is called a natural log, and the base of a natural log is going to be the exponential constant e. Okay, the base is e. E is equal to 2.72 something, 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 something. So 2.72 is equal to e. It's kind of like pi. You know how pi is equal to 3.14, yada, 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 yada. Well, in the logarithmic exponential world, there's a common constant, and it's e, and that e is equal to 2.72 something, right? So whenever you see ln in your mind, you need to say, okay, that means log base e. So if I wanted to rewrite this, this could be log base e of x. Okay, this one could be written log base e x minus 7. This one is the hardest for students to remember because all the letters change. Like, you don't even use log anymore. They take that all away. They take all of this stuff away, log base e, and they replace it with ln. And they mean the same thing, okay? When you look on your graphing calculator, you actually have the ln button. It's right here across from the 4. So if you press ln, it will show up in your calculator. And you have to think in your mind that that means log base e. Okay? Now, with these rules, you should have everything you need to solve an equation that has logs in it. Okay? Hope this is helpful. See you next time.